Good afternoon. Today we are going to see problems on constant acceleration that is related with our kinematics. So in last video we have already seen we are going to divide it into two parts. That is kinematics and kinetics. Now for this you have to go to Civil Engineers Technical Hub. In this you have to go to playlist, and in that you have engineering mechanics folder in which you will see the videos related with mechanics. Now we are with basic concept equation of motion, that is in kinematics. So this basic concept and equation of motion, this already we have seen in last lecture. Here also we are going to revise it a little, and then we are going to solve the problem on this only, equation of motion for constant acceleration. Now, equation of motions already we have gone through it. I will just revise it. And we have, this is first equation, which is V equal to U plus AT, provided my acceleration is constant. That is most important. Second, we have A constant, and after that only we are going to use this equation, which is S equal to UT plus AT half AT square. Here also we have clearly mentioned we have A constant. And here also, if A constant, then we have equation that is V square equal to U square plus 2AS. So likewise, we have to go to solve the problems using these equations. Now we are going to solve the problems. These are from 2019, and we have given problem that is automobile A and B are traveling in adjacent lane at t is equal to 0 and have the position and speed as shown in figure. Knowing that automobile A has constant acceleration 0.6 meters per second square and B constant deceleration 0.4 meter per second square. When and where A will overtake B, also determine the speed at that time. So here velocities are given. So we can have, now we will solve this problem. So we have given, we will write data related with A. So we have A. Now VA is given. How much? 15 kilometer per hour. So 15 kilometer we have 1000 and hour we have 3600 seconds. We have to convert value always in meter per second. And then I have this value 4.17 meter per second. Acceleration of A is given 0.6 meter per second square. Now if we will write for B, then you can see for B, we have VB 23 kilometer per hour. Now this is initial. So instead of V, I will say actually this value as U. So I will write it as UA, initial velocity. This also I will write it as UB, that is initial velocity. And this is 23 into 1000. Generally, V, this we are using for final velocity. And we have this value that is 6.39 meter per second. And deceleration is given, means we have A negative minus 0.4 meter per second square. Now we have A position is here and distance between this A and B, this is clearly given, which is 25 meters. Now this is their initial position. So I can say this is initial and at t is equal to 0. This is initial at t is equal to 0. T0. Here also I have T0. And now we are going to start the motion of these two. So in that motion, VA will move here, but velocity, we do not have this velocity. So that we have to find. So let us, we have velocity will be VA. We do not know that velocity. And for B, VB, this is actually initial. We do not have this velocity. So we have VB, that also we have to find. Now, distance covered by B, this distance is x. And what will be time? So we have time t. Now, distance covered by B, so we have now x and this 25. So distance covered is x plus 25. This distance covered by B. So now if we will write x and x plus 25. Now we will make it. So I will write here, we have x a equal to UAT plus half AAT square. T is same for both. Now XA we have x plus 25. UA we have 4.17 into T plus half into 0.6 T square. And if I will little bit simplify it, I have x plus 25 and that is equal to 4.17 plus 0.3 T square. Now if I will write it for B, then this x that is equal to UBT plus half AB into T square. Now x we have, UB we have 6.39 T minus, because it is deceleration, into 0.4 T square. And I will get value of x, this is equal to 6.39 T minus 0.2 T square. I will mention this is equation 1 and this is equation 2. Now I will substitute x from 2 in 1. Substitute x from 2 in 1. And then by substituting this value, we will get, now x we will put this value 6.39 minus 0.2 T square, which is equal to, or x plus 25, and this is equal to 4.17. So this is T actually, 4.17 T plus 0.3 T square. Now you simplify this, you will get 0.5 T square. Here also T is there. I am missing this T, minus we have 2.22 T. So we have 2.22 T minus 25 equal to 0. And from this quadratic equation, I will get value of T equal to 9.63 seconds. Now what we have to find, when and where A overtake B. So A will overtake B at time T is equal to 9.63 seconds. And when it will overtake, so we have to find value of x, and value of x we will get, that is equal to 6.39 into 9.63 plus, sorry, minus 0.2 into 9.63 square. And from this I will get value of x, that is equal to, I will just calculate it, 6.39 into 9.63 minus 0.2 into 9.63 square. And we have this value 43 meters. So A overtake B from B after 43 meter, or we can find x plus 25, or x A value I can find, which is equal to 4.17 into 9.63 plus 0.3 into 9.63 square. And if you calculate 4.17 into 9.63 plus 0.3 into 9.63 square, and we have this value 68, we can say 68 meters. So now you can see we have x, this is equal to 43 meters, and from A, this distance obviously we have 43 plus 25, and that is equal to 68 meters. So A overtake B, A overtake B at 68 meter from its position in 9.63 seconds. So likewise, we have to solve it. So now we will go to the second. The car comes to complete stop from initial speed of 50. Now we have only one vehicle, so we will write given data. This is most important. If you can write given data, you can solve problem very easily. So let us, we have a car and data is given for this. So data is given, a car comes to complete stop from initial speed. So this initial speed is given 50 meter per second in a distance of 100 meter. Means this car's final velocity we have 0, because complete stop they are saying, means I have final velocity 0. And during this, how much distance traveled by this car? So that is 100 meter. And then what would be the stopping distance as from an initial speed of 70. So now you can see what is given, u is given, s is given, t is not there. So which equation we have to use? We have to use v square equal to u square plus 2as, because time is not there. Now final velocity is 0, u we have 50, so 50 square plus 2a, and s is given 100. And from this, we will get value of A, that is equal to 12.5, but minus sign, minus 12.5 meter per second square. So this is my acceleration of first vehicle. So this is most important. So I will mention A, I have minus 12.5 means deceleration meters. Now with the same constant acceleration, what would be the stopping distance? So that means now we have another car. And then this is moving. And this is somewhere here, I do not know exactly. So we are been like this. And initial velocity is given 70 meter per second. Again to stop means finally 0. Now we are interested to find S, but A is same, which is minus 12.5 meter per second. Try to draw the diagram and write data in the diagram. And then from this, we are going to use again same equation, v square equal to u square plus 2as. Now v is given how much? 0. U is given how much? 70 square. Now a is minus, so minus 2 into 12.5 into s. And from this we will get value of s, that is equal to 196 meters. 196 meters. So same constant, what would be the stopping distance? So car with initial velocity 70 meter per second, with velocity 70 meter per second, having deceleration 12.5 meter per second square will stop up at 196 meter from its initial position. So likewise, we have to go to the problems. Now this problem was asked actually in 2022. So this was asked in 2022. I have considered that also over here. A car start from rest. Car start from rest and with constant acceleration achieve a velocity of 15 meter. Again, we will draw a car. So I already mentioned, try to draw the diagram and write down the data. So the given, what is given? Start from rest, means my initial velocity is 0. Achieve a velocity of 15 meter per second. So we have this 15 meter per second. Now car, we are touching over here, otherwise you may think it is flying. So no, u is 0. Final velocity I have 15 meter per second. And distance cover is how much? So we have distance cover, this is 200 meters. Now determine the acceleration of the car and the time required to attain the velocity. We have to find both. Now first we have to find acceleration and then time. So now you have to see, we have V, U, A. This data is given, and therefore which equation we have to use? We have to use V square equal to U square plus 2AS. Now V is given how much? 15 square, U is 0 plus 2 into A, and S is given 200. And from this, I will get A, that is equal to, I will just calculate it, 0.56 meters per second square. 56 meters per second square. So we have 225 upon 400. Now we have to also find how much time. So my acceleration is 0.56 meter per second square. They have asked this also. And then time, so I have to use V equal to U plus 80. You can use S equal to UT plus 8, half 80 square, but that will be more calculations. Here we have less calculations. 15 equal to 0 plus A is 0.56 into T. And from this I will get T is equal to 15 upon 0.56. And I will get this value, that is 15 divided by 0.56, 26.79 seconds. So acceleration of the car at 200 meter is acceleration of the car is 0.56 meter per second square, and it reaches, or it will reach 200 meters in 26.79 seconds. So likewise, we have to solve the problems and we will get the answer. If you will use S, that also you can use S equal to UT plus half 80 square. S we have 200, U is 0, so this term becomes 0, half into 0.56 into T square. And you can see T square equal to 200 divided by 0.28. And from this we will get T, I will just check it, 0.28, and the root of this we have 26.73. So little difference we are going to get. From this we will get 26.73 or 74 likewise. So answer you can have plus minus 0.3. And this is 0.03. We have 0.3, that it's okay. So likewise, we have to go for the problems related with our constant acceleration. So now we will stop here only. Remaining part we will see in the next lecture. Now, if you are not subscribed, subscribe YouTube channel Civil Engineers Technical Hub. You can see more videos on engineering mechanics. So thank you.